going to use stack to implement convert decimal to binary. Okay, let's just go through how to convert the decimal to binary first, okay? So we're gonna do this through an example. For example, we have a number. Okay, 252. We're gonna divide it by 2. So now we have, right? Then 52 divided by 2, we have now. Okay, so this is basically how we do it, right? So we have a so 252 divided by 2, we have a result 126 with the remainder 0. Right? And then we do the same thing here. 126, what we divided by 2, we got 6. We got remainder 0. We result 63, remainder 0. Okay, now let's do this again. We got 63. We got remainder. Okay, let's do this again. 63 divided by 2. So we 63 divided by 2, we get a result 31 with a remainder 1. Okay, whole thing again. Like just want you to see it's quite simple actually, right? Remainder 11, got a 5, 1. So 31 divided by 2, we got 50, remainder 1. So you keep doing this. 15 divided by 2, we got a 7, remainder 1. And 7 divided by 2, we got we got a 3 and remainder 1. And 3 we divided by 2. We got 1, remainder 1, and 1 divided by 2, we got a 0, and remainder 1, right? So 1 divided by 2, which is 0, right? 5, right? We got it. So when here is 0 and this 5, we just say the remainder is 1 and the result is 0. When we got a decimal here. So now let's look at this. It's quite so this one, so when we read the decimal number, right, we're gonna read from the bottom to top. Let me change my pen color. This is our most significant bit, and this is our least. This is our least significant bit. So when we read this number, we're gonna write down the binary number from the top. So we got 0, 0, 1. Let's count how many 1 we have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now let's do a test, see if we got this number right or not. Okay, let's change this binary. So this is the binary number of 252. but we want to make sure that we got this number right. So now let's revert this binary number into a decimal number. Okay, so this is how you do it. It's like 2 to the 0, 2 to the 1, 2 to 2, 3, 4. Oh, sorry. So basically, when we got a 0, is like 0 times 2 to the 0 is 0, right? 0 times 2 to the 1 is 0. And 1 times this is 4, 8, 16, 32, 6. So now how we get the decimal number is that we add those numbers together. Okay, so we got 12 men. So we got 28 to 32. We got 60, 64 is 124 plus that. We got 252. And it is the same as this one. So we know we got this binary number right. Right? Okay. So now let's think about this as a stack, right? So when we are dividing this number, okay, when we're dividing this number, let me just do this really quick. Let's see, I have a stack here. So stack. So every time I divide this this integer into 2, right, I got a remainder and I push that to the stack. And just keep doing this. One, right? So this is this is the binary number on our stack. So when we want to get this number, we just need to pop this out, right? And save it to a string, or we can save this to a string or array, right? We can just save it to a string. So every time we pop this off, and we got our decimal number. So it's actually really not that hard to use the stack data structure on this problem. I think it's mainly to understand how to convert decimal to binary to decimal, and then just use stack super easily in this problem. Now let's go to Python and see how to actually implement this solution. Yeah, I will see you there. Just yeah. Now let's implement this solution, convert the decimal number to binary number using stack. The first thing we need to import our stack class. And then now let's define convert decimal to binary. Okay, we take in a number. So first situation is like we need to create a stack to store everything. stack created, and we need to check if the number is already 0, right? We just need to return the number, because if you know mathematics, 0, divide anything is 0, right? So if number 0, return the number. Okay. Okay, let's say, well, number is greater than 0. We first thing we need to get the remainder. So in Python, you just need to, let's just store the remainder in this one. So this is how you get the remainder of a number. You use the percentage sign. So after we get the remainder, we just need to push it to our stack. After we push that remainder to our stack, we need to divide that number into 2. So Python has a special operator, is like // that means that we'll round this number to the nearest whole number, which, for example, 12 divided to 13 divided to 2 will round it to 6. So let's say 2. And then after it gets to the point, 0, after it divided to the last possible number, we get a whole stack of the remainders, right? So how do we gonna save when we pop everything out of the stack, we need to be able to show it to other people, right? So here I'm just gonna create a binary number, and I'm gonna make it to an empty string. So when I print out, it's gonna be a string. And then let's say, well, while the stack is not empty, we keep popping things out. So binary number equals to, keep adding whatever pop out from the stack to that binary number, right? But we need to convert that integer numbers into strings. And then in the end, we just need to return the binary number. Okay, and that's it. Let's do a testing. So for example, what the example we did was convert. So function, we just put in 252. And we save this. Oh, save this class. Because I already created one of these, I'm just gonna say temp. Yeah. And then when I run this, see, we got the number. Here it is. We got the number we wanted. 6 ones and 2 zeros. So this is how you implement convert decimal number to binary numbers using stack data structure. I hope this was helpful for you, and you can find all the codes from my GitLab. So I will link everything in the description box. Thanks for watching. See you next time.